Here's the color changer. It's connected to a light board with red, green, and blue LEDs, like these. This is a common color model used in TVs. Look closely at your monitor. Come on, really close. Everything on your screen is made out of tiny red, green, and blue dots. We're going to do the same thing with LEDs. I've got the color changer hooked up to a 16-volt wall wart. When I plug it in, the auto fader program starts. For the demonstration, I've got this running 10 times faster than normal. When I plug in a USB cable, the auto fader program stops, and the color changer waits for commands from the PC. I'll use a simple serial terminal program to send color settings. Each color has 255 intensity levels. First, the setting for red is entered, followed by green, and finally blue. The auto fader program resumes when we disconnect the USB cable. Now let's look at how it works.
How does this work? It's very simple. Now here's what happens.
I chose the microchip PIC 18F2550 as the microcontroller for this project. It supports USB, it's got a ton of program space, everything we need to make our color fader. As far as support gear goes, we need a decoupling capacitor between the power and ground pins, and a resistor and diode for the programming header. We need a couple of capacitors for the USB peripheral, and a 20 MHz crystal. Don't forget two 27PF caps for the crystal. Crystals vary, but 27PF usually works. We need a USB port. We'll connect the USB power line to one of the PIC pins. That way we know when the USB cable is connected. A PIC pin can't switch more than a single LED. Instead, the PIC will switch the LED ground connection with a FET. We need 3, but I'll just draw 1. 3 small indicator LEDs show status info. I'll just draw 1 here. The circuit runs at 5 volts, so a 330 ohm resistor is perfect. The microcontroller runs at 5 volts, which is provided by a bog standard 7805 regulator. The 7805 needs a decoupling capacitor between each power pin and ground. We'll use a 7812 to provide a 12 volt supply for the LEDs. And that completes our design. The design leaves tons of room for updates. We can add things to the headers, update the firmware. The serial port's exposed. That means it's easy to control this with another microcontroller or even the PC serial port. We could pre-amplify a microphone, feed it into the analog to digital converter, and do beat detection based color fading. Have fun mixing colors and play safe.